Look at it, it looks like a bridge where we have a support at this point, and this is the point where we have 5 cm from the end of the meter rule. At this point, 5 cm. This is the 5 cm meter rule supported here. Then I know that the meter rule has a mass, but I want to support the meter rule, the mass of the meter rule, with the 100 gram mass labeled P. The sellotape should be used to wrap this one and label it P, but it depends on what WASSCE wants to achieve. But I am doing it this way. This is my concept, and I'm trying to support the weight of the meter rule by helping it at the center of gravity. This is hung at the center of gravity. And at a place, 10 cm from the place where the spring is hung, this is the spring, is hung. So from where the spring is hung, I put another one, a mass hanger, such that the mass of the hanger will be ignored. It's going to be negligible. Then what I'm going to be doing is, this is 20 gram. I'm going to be using it to slot here. When I slot it here, then I take it for the first 20 oscillations. But I know that there may be a kind of wobbling, but I have to prevent it. But if there is another way, you can also use this and place it on top here so that it will be strong and avoid wobbling. That would be perfect. So this is my spring, the helical spring, which I use. One thing I want you to know is that if without this spring, this meter rule would have fallen down this way, but this is the upward force through this spring, while these are the downward forces. According to the principle of moment, upward forces must be equal to downward forces. So we are going to carry out our experiment. And this is my stopwatch. Remember, stopwatch was given. And this is my stopwatch I'm going to be using. Then these are my 20 gram. But remember this, they said this should be recorded as M. So let's get over it. Okay, you're welcome, my friends. Please don't forget to, I'm begging you, don't forget to hit the subscribe button, like this video, and share it. Very importantly, please share it on your Facebook and WhatsApp, please. It's going to help somebody. So this is the way I have set it up. If you really followed from the beginning, where I showed you clips of when I was preparing it, and everything I did here is for a reason. Everything I did here is for a reason. Now, this particular one is labeled P according to the instruction of the WASSCE white paper. This is P. You have to label this on P because it is 100 gram mass, and I put it at the center of this meter rule, at the center of gravity of the meter rule. That is where this is hung. That means you have to first measure the center of gravity of your meter rule. Then this one is going to be the M according to the instruction also. This M is fixed at, or is suspended at 80 cm, which is 10 cm from where the helical spring is suspended. And this is the helical spring. I suspended it at 10 cm mark from the end of the meter rule. This is 5 cm mark. The idea is that the total downward forces, these are the downward forces. This is downward force number 1, downward force number 2 is going to be equal to the downward force which is acting on this spring as a tensional force, upward force. Without this spring, without this thing hung at this point, this particular system will not be balanced horizontally. So I'm combining Hooke's law and the moment of forces, the principle of forces, all together in one. So I'm going to make sure that this place stays 5 cm throughout this experiment. So I have my stopwatch here, and my stopwatch, I'm going to be using it to measure the period of oscillation for every mass which I'm going to be hanging. After this one, I hang another 20, which is going to be 40. After one, I hang another one, which is going to be 60 and 60 and 80, as the case may be. That is the idea of this experiment. Please, I'm also going to show you an illustration of how the graph is. But if your problem is how to plot the graph, please go to the playlist. You are going to see a question I have treated on how to plot graph. You will do it. But I will analyze how the graph is going to be. Okay, let us start. I am going to make a little depression of this particular meter rule, press it down, then carry out my first 10 oscillations or 10 oscillations, and then we record it according to the instructions. So, but make sure it doesn't wobble at the same time oscillate. No. So, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, this one is wobbling, but let me take it again. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Oh, okay. Another way you can place this one is just by placing it at this point and then using paper tape, this kind of tape here, to bind it together. Bind it together with the meter rule to avoid it falling off. So, but I'm going to keep it this way. I'm going to keep it this way. I'm going to neglect some systems, some factors, some forces here. So, but my depression is going to be too small to avoid 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. As I said before, this place must be at 5 cm mark. And this is the place, the mark of the knife edge, where the knife edge is put and is fixed. It doesn't change. And the 100-gram mass labeled P must be at the center of the gravity of the meter rule, and that position does not change. Then I'm going to be putting a P which has a variable masses of 20 gram, 40 gram, and all the rest of them. And I'm fixing it at a mark 10 cm from the spring. That should be 80 gram. I mean, that should be 80 cm. That is where I'm going to suspend this mass. Why this helical spring is suspended at a point 90 cm, that is 10 cm from the end of the meter rule. And that is going to be, like I said before, this is combination of principle of moment, just principle of moment, but then I have to combine with the use of helical spring such that the downward forces must be equal to upward forces. So let us start. I am going to first put this. When I put this, remember what happened? There must be, according to the spring, there must be an extension. And the extension is as a result of this force which has been added. So the added force must be equal to the extension, provided that the force constant is provided that the stiffness of the spring is constant. But in this case, I'm going to find my first 20 oscillations, because as mass has increased, the oscillation or the time or period for 20 oscillations or 10 oscillations will also have to increase. So this is all we are just going to be doing. This is what I've been able to figure out about the whole experiment, and based on the apparatus provided for. Please, I am begging you, don't forget to subscribe, like, comment, or give us a comment of encouragement, and always share this video. It's very necessary. If this is the first time I've seen this video, you know that electricity is also available and that of the optics is available. So let's get over it. Also remember that I have Mass Physics on Facebook and Mass Physics on TikTok, Mass Physics on Instagram. Just look for me. The same icon on the profile picture of this channel is the same for all of them. All right. I'm going to start with the first 20 oscillation. What I'm going to do is a little oscillation. As it's moving faster, I move faster. When it's moving slower, I move slower, because as I'm increasing the mass, the oscillation will be moving slower. That means the time or the period will be increasing. So we must take that into account. If not, you'll be frustrated in this experiment. So I'm going for the first one. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. and this is 2.7. I have 2.7 as my time. That is my T1. Remember, you must follow the guideline for writing your table of value. T1 in seconds, which is 2.70, 2.70. Then I'm going to do it again. 1, 2, 3, 4, 5, 6, 7, 8, 9. No. It's wobbling. Just a little depression will be fine. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 2.8. So I have T2 in seconds, 2.80. So the total time taken is going to be 2.7 plus 2.8 divide by 2. That is 2.75. And T mean is going to be T1 plus T2 divided by 2. Divided by 2 is going to be 2.75. Then I'm going to have capital T, which is period, time all over the number of oscillation, which is 10. And then I'm going to find T square, then second square. Then this is so I'm going to increase this mass, increase it to next one, which is 20. So when I increase it to 20, I will also do this. 1, 2, 3, 4. No, it's okay. Now remember, this one is slower because the time is going to increase. It's a little slower. Also move with it according to the way it's going. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So this is what I came up with. This is my table of value. If your problem is plotting of graph, go to Vindall's concept. Go to my YouTube, Vindall's concept. This is YouTube. Go to my YouTube, Vindall's concept. If this is not your YouTube, go to my page. Go to my channel. Go to the playlist. You see a playlist. Enter the graph or physics practicals. You will see where I say become an expert in plotting graph. I plotted 2 graphs there. Please go and learn how to do it. If you are not stronger, you don't have a very strong hand in plotting graph. So this is the table I came up with for this 2023 #1 physics experiment. And this will help you. But what I'm going to do now is I'm going to use this table to analyze what is going to happen. Because if you're looking at the table, you realize that this is the mass and this is my time, the period for 10 oscillations. I did this for 10 oscillations because this is the answer I got. This is the time. So what you notice that the time is increasing as the mass is increasing, which is true for this formula. T is equal to 2 pi m over k, the square root of m over k. You realize that the T is directly proportional to the square root of m. Whatever the m is, it means that the m will be changing as the oscillation is changing. But I have already performed the experiment. You can still watch the experiment. If this video is not, you have not seen the video for the practical, you can still go and check it. So this is the table of value I came up with. This is my own guide for what is coming on the day of exam. I wish you good luck, but please don't forget to leave this channel, but subscribe and share this video with your friends, and also give us a very good comment. Thank you and God bless you. Welcome to Vindall's concept, and today I have a very special class for you, and this is physics practical for WASSCE 2023. And the first question, the #1 question that they gave to us, if you look at that question very well, they say that they are given a knife edge, a meter rule, that a mass of 100 grams will be labeled P, and a mass of other ones like 20, 40, 60, 80 will be labeled M. Then they also gave us a helical spring. This is called the helical spring. And then they gave us a rotor stand. This is a rotor stand. So I have looked at them and was able to come up with this experiment. What is the concept of this experiment? If you look at this experiment, the setup here, you will realize that I decided to put the 100 grams at the center of gravity of the meter rule. Why did I do that? I did it in order to help the meter rule, because the mass of the meter rule is at the center of gravity, to give it more weight for it to be able to do an oscillation, because we are going to do an oscillation. And when you do this experiment and finish it, your table of value is going to be M, then T1 in seconds, T2 in seconds, then you now have T equal to T1 plus T2 all over 2 in seconds. Then, when you are done with these ones, you now still go further to have T, capital T is equal to T all over N. Then this is another one, also in seconds. Then you have T square, which is also in second square. So please, it's the space that made me to continue from here. So this is going to be here, and this is another place here. So what you are going to do is, first of all, when you slot in 20 grams here, because you may use a mass hanger, or you may use a sellotape or paper tape to be masking it, place it tight at that particular point. And if you see this one is 80 cm, which is 10 cm from the helical spring, while this one is at the 90 cm mark, and this one is at 5 cm mark. So for every 20 gram, there is a time recorded 40, 60, 80, and probably 100. And this is what you're going to have. Now, what I came here to do is to show you analysis of how the graph is going to look like. But what you have to understand is that the time for this T for 20 gram will not be the same as 40 gram, because the period will be changing. And also, if you want to look at a full graph, a full experiment, which I have done, you can also check my YouTube channel. You will see that I have already done the experiment. So the time is increasing. So the increment in time leads to the increase in mass of the body, leads to increment in time, or which is called increment in time, which is called the period. The period will be changing. So as the period is changing, and that's all. So when we come to this part, remember that if I am going to take T square is going to be equal to 4 pi square M all over K. So remember, I'm going to be plotting a graph of T square against M. Yes, therefore I'm going to have T square is equal to 4 pi square over K in M plus C. This is the equation we are going to be dealing with. In this equation, you realize that this C, there is no value for C. That means our graph is expected to pass through the origin. It may not necessarily pass through the origin as a result of one mistake or the other, as a result of some irregularities while carrying your experiment. But it could pass through the origin because the intercept, which is C, is 0. But then what will be the value? What will be the value of your slope? The slope of this graph is going to be given as S is going to be equal to 4 pi square all over K. Because K, you don't know what the K is all about at that point. But whatever your K is, because the experiment, you must find the first constant, which is K. Whatever it is, this is how you are going to find experiment. So this is all you are expected to do in that number 1 experiment. And also, looking at this body, you also remember that the total downward forces must be equal to upward forces. That is why I put this T, which is a tension, a force acting through the helical spring. That is what I came up with for this experiment for number 1. Please stay put, because other experiments for electricity and light will be coming your way very shortly. But please don't forget to share these videos, subscribe or follow, depending on the social media you're following me, and give us a very good comment for encouragement to come up with more content. Thank you, and God bless you.